Okay. Hello, everyone. Welcome to Concordia University's Forest-Based. Thanks for joining us for today's event. This is part of the Philosophy Department's annual Ethics Lecture Series. Today's event is Ethics Modeling, a new applied ethics for tech design with Jason Millar. But we'd like to begin by acknowledging that Concordia University is located on unceded Indigenous lands in Tiohtià:ke, Montreal. And we respect the continued connections with the past, present, and future, and our ongoing relationships with Indigenous and other peoples within the Montreal community. And here at Force-Based, we work with our university community to help mobilize knowledge, co-creating daily activities, examining research questions and projects, things happening across the university. We're also running today's event as a live stream, both to YouTube and via Zoom. So there will be some Q&A a little bit later on. If you have any comments, questions there, just pop those into the chat and we will do our best to read those out. Those of you here in the space, you maybe know this already, but just raise your hand and we'll run a microphone around so that everyone can hear. Okay, with that, it's very much my pleasure to pass the microphone over to Assistant Professor, Department of Philosophy, Dr. Anna Brinkerhoff. Anna, over to you. Great to have you.
Thank you so much, and thanks everybody for coming. We're really thrilled to have you here. I'm thrilled to introduce our speaker today, Dr. Jason Millar, who is the Canada Research Chair, let me make sure I get this right, I have notes, in Ethical Engineering of Artificial Intelligence and Robotics at the University of Ottawa, with faculty appointments in both the Department of Philosophy and the School of Electrical Engineering and Computer Science. He is also the director of the Canadian Robotics and Artificial Intelligence Ethical Design Lab. Dr. Millar, we're thrilled to have you here. I'll pass that over.
Thank you so much. Thank you so much for the invitation. I'm really excited to be here. I'm going to be talking about work that has been ongoing since, I would say, 2011, 2012 in various forms. But today's the first time I'm talking about this work in this way in public. And, you know, I've come to a place where I've been looking back on work that I did during my PhD, even before the PhD, and work that has been ongoing since. And it's funny, you get to a place where you start framing things and understanding your work in a different way. So although it's the first time I'm talking about this work in this way, talking about some of the techniques I've used to do my applied ethics work over the years in my dissertation, really, I want to frame it as a new way of thinking about doing applied ethics. That's certainly how I'm starting to think of it. It combines a lot of my thinking about tech design and kind of overlaps with engineering. I'll get into that a lot, actually, in the talk. But I'm super excited to be talking to you about this today. So let me get started here. What am I going to do today? I'm going to do a quick introduction, set a bit of a frame, give you a sense of who I am and how I approach the work that I do, and what we do at the lab, the Canadian Robotics and Artificial Intelligence Ethical Design Lab. I'll talk a little bit about that. And then I'll start setting the context for this thing I'm calling ethics modeling. I'm going to go into the basics. So just a quick show of hands. I'm kind of curious to know who's in the room. So I don't know if people online probably won't be able to see this, but just a sense, who's here from philosophy? I know this is a philosophy event. Oh, wow, the room's filled with philosophy professors, students. I don't know who you are exactly, but I'm going to assume a mix of everything. Who's here from outside of philosophy, or maybe has a background outside of philosophy as well? Okay, okay, some overlap then. Any of that overlap in technology-related fields, computer science, engineering, show of hands? A few people, okay. So and a little bit, I see one of these as well. So yeah, you're like, this talk is for you, because we're going to talk about a lot of this kind of stuff today. This is good, okay. Then I'll talk about ethics modeling. So I'm going to set the context. I'll talk about ethics modeling. What is it? Like, what am I talking about? I'll give an example then. This is an example that I'm drawing from my PhD work. Like I said, I would never have called it ethics modeling when I was doing my doctoral work, but thinking back on it, 10 years down the road, I've come to understand it differently. And then I'll try to, give you some takeaways so you walk away kind of like just, understanding what I was doing. And then we'll get into the Q&A, which should be a lot of fun. So it's about an hour for the talk, an hour for the Q&A. Okay, here's the introduction. This may be short. But I want to start with the problem statement. What am I here to talk about? What's the problem that I'm addressing in this talk? Kind of like a short argument. Technology, AI for example, simultaneously solves problems and unleashes harm at scale, right? We know this about technology. Technology does amazing things. You know, I don't have to talk about all the amazing things. I mean, here we are in a room full of technology. It does wild and unreal things. Sometimes it seems like magic. But that magic can also go sideways, what we're seeing with AI, with other technologies, nuclear. I mean, pick your technology. We know that technologies do good and they do harm. From the perspective that I'm presenting, and certainly from anyone's perspective who studies ethics of technology or like the social implications of technology, we need more ethical technology design. We need design that explicitly and more effectively anticipates and mitigates technological harms, right? I think that's just I hope that's uncontroversial. If it's controversial, I'm happy with the controversy. For this to happen, my perspective is that we need to develop a new kind of design expertise, and that's what I'll be getting into today, one that prioritizes the socio-technical or ethical analysis of technology to make better technology. Okay. The goals today, what I'm hoping you'll take away is that I'll teach you a little bit about ethics modeling. I hope to convince you that ethics modeling, or something like it, you know, it's one approach to doing to solving that problem that I was just talking about. But that something like this is necessary for better tech design, and I mean tech design that produces fewer harms and maybe more benefits, if you want to think about it that way. And I also want to convince you, this is important, and this is good, philosophers in the room, that philosophy and philosophers in particular have the lead role to play in ethics modeling. That's something that I think is like a big takeaway that I want you to have today. Okay, some strategic caveats here. So this is very interdisciplinary, this talk. And so by design, one of the things I do sometimes is like slip into stereotypes. I'll stereotype what philosophy is, what ethics is. I'll talk about it generally. I'm not going to get into the details. I'll point to the things that I think matter most for getting the work done that I'm trying to do. I'm certainly not trying to intentionally mischaracterize what philosophy or ethics is. And we can have a conversation about that during the Q&A. But I try to be fair, like to what philosophy does and what philosophers are trying to engage in, at least insofar as ethics is concerned. And then same thing with engineers. I'm going to do that for both of them. So it's not going to be, I'm not trying to ruffle feathers here. I'm just trying to like make broad generalizations so we can get into the conversation. And I'm doing these things intentionally to make the work a little bit more accessible to a broad audience. You kind of have to gloss over some of the details. It's just going to happen. And I raised this in a room full of academics because academics care about details, right? So I'm going to gloss over those details a little bit in my talk. And again, we can talk about this in the Q&A. Okay, so who am I? Well, I started my professional life as an engineer. I studied engineering, worked as an engineer for several years before turning back to philosophy and went and studied a lot of philosophy, from undergrad all the way through to the PhD. So most of my academic training is in philosophy. I think like a philosopher, but I realize I also think like an engineer, and there are ways, I mean, you've probably been accused of this by your friends, probably also your family, of thinking in a particular way, because we get socialized into the academic fields or fields of expertise that we pursue. But I really cross over in both of those worlds, having kind of lived in both. And I just can't help it. It's just the way I see the world and kind of function in the world. I'm an associate professor. I'm in the School of Engineering, Design, and Teaching Innovation. I switched over from electrical engineering, started at electrical engineering and computer science. I do have the Canada Research Chair, and I'm cross-appointed with philosophy. So I still straddle both of those worlds in the work that I do and the research that I do. And I'm the director of this lab, CRADLE, the Canadian Robotics and AI Ethical Design Lab. I'll talk a little bit about that, and then I'll move into the main content. But I do want to plug the lab and explain what we do there. It helps also to frame the talk that I'm about to give. So at the lab, we focus on 3 overlapping areas of research. There's the applied ethics, which really draws from my philosophy background. There's the engineering design aspect, so very practical, like how do we get stuff done in engineering. that always overlaps with applied ethics. And then there's a lot of policy work that I end up doing. Recently, it's mostly AI policy. I've worked on a little bit of robotics, like autonomous vehicle policy in the past. But those are the three overlapping areas. And in the lab, I make a point of always, if we're doing research, it's in those shady areas, like the overlap in the Venn diagram, sometimes right in the middle, but never only in one field. Like I really try to drive real interdisciplinary research as much as I can to just encourage that type of thinking. And I think the talk today will explain why I think that's important. There's like 6 categories of research that we kind of broadly fall under. Policy, design tools, I'll talk about that a little bit today. Healthcare, robotics, and AI, that's a little bit in today's talk. We do work with artists to try to bring artists into the design process as well as like equal partners and providing like critical design thinking for technology. Automated mobility, I'll talk about that today. Autonomous weapon systems, it's something that we have projects on. I won't talk about that today, but we can talk about it in the Q&A if you want. Okay, that's the intro. Let me start by setting the context for ethics modeling. Okay, and I'm gonna run through a bunch of fundamentals now, but the fundamentals are important. I'm gonna start by talking about what is ethics, and I'm gonna use an example. So this, again, I was told that maybe online, like people from the public, there may be non-philosophers in the room. So here's my take on ethics, how I describe ethics for the work specifically that I do. I'll start with this though. Here's a quote from a couple of weeks ago, maybe a month ago now. Technology moves at the speed of innovation, but adoption moves at the speed of trust. Now this was our current Minister of AI and Digital Innovation, Evan Solomon, speaking on power and politics. When I heard that quote, I thought, okay, here's a very descriptive kind of quote about how technology kind of like moves around and gets adopted in society. There's this key ethical piece, though, that I want to add in that I think is very exemplary of the kind of shift that we naturally do when we study ethics. We question the descriptive thing, like technology. Well, should it do that? And then we add the maybe run through the arguments and this is an area that I work in, thinking about trust and trustworthiness of AI. And immediately I was like, oh, he's missed an important piece there. Adoption ought to be moving at the speed of trustworthiness. Like he's gotten a term wrong and he's using the wrong, he's focused on trust instead of trustworthiness. Very philosophical, right? Very loaded, thinking about the specific words you're using, shifting to a normative evaluation. So that's like me, the same day and then I immediately started writing. I've been using this as an example ever since. I have nothing against Evan Solomon. I just think he needs to focus more on the trustworthiness of AI because he's really trying to get us all to use AI. Okay, how else can we think about ethics though? So it's there's an example of doing ethics, I guess. Ethics is, and again, I give this talk to a non-philosophy audience as well, like this particular part of the talk. Roughly speaking, again, maybe this is going to offend some of you. It's a branch of philosophy from the Western tradition, which is where I come from. Kind of gets split up. I'm thinking of the course catalogs that you see in a philosophy department. There's meta-ethics. I'm still not 100% sure what meta-ethics is exactly. I studied it a little bit, but never really sunk into it that much. Normative ethics, much more getting into my kind of domain, thinking about ethical theories. Again, this glossing over details about what's right or wrong, what's permissible or impermissible, how should we be as human beings? You've got these theories that pop out that everybody talks about, utilitarianism, deontology, virtue ethics, kind of providing these ways of evaluating our actions, the way we live our life, and coming to some sort of normative claims about what we should be doing or what we ought to be doing. Then there's applied ethics. This is where I spent most of my time. Applied ethics is a funny thing because sometimes, as I learned as I was going through philosophy, it kind of gets pushed off to the side a little bit. I don't know what it's like at Concordia, but different philosophy departments are very different when it comes to applied ethics. It's we teach these courses because we have to. I love applied ethics. Maybe it's the engineer in me. It's the most relevant to the things that are going on in the world. It's kind of why I got into philosophy without knowing it. And this is all about like how we should act in particular circumstances. Like how do we solve these thorny questions that we have about like normative issues, right? Like how should we run businesses? Like there's like a lot of applied fields, right? Business, bioethics. There's engineering ethics, but that's what I'm going to be talking about today. We don't really talk much about engineering ethics in philosophy departments, but we talk about bioethics and things like that. So I'm going to focus on applied ethics for today's talk. This is what we should do in such and such a circumstances. This is why it's applied. It's very specific to a problem at hand. There's a real world problem somebody's got to solve, and applied ethics comes in, and people make arguments about how we should respond to that problem. So examples: who should define our AI policy? What kinds of biases are permissible in an AI model? I'm using a lot of AI and robotics examples. It's just where I kind of live. How should we determine what is safe enough for an automated vehicle, for example? Like who gets to decide that kind of question? Now, coming from an engineering background, it took me a while to realize what was going on here, but you can contrast this pretty starkly with engineering and science. So in engineering science, we mostly study, like in terms of what we're taught, descriptive theories and facts. How do you describe the world factually? How do you predict what's going to happen? It's devoid of these normative questions. There are normative questions that you can find in engineering, but not typically as the focal point of education or research. So for example, you might be concerned with what is the most efficient model for a particular application. Is it possible to do facial recognition with AI, like just as a matter of fact? Is there any bias in my data set? And somebody else maybe tells me what bias I should be looking for and how to detect it. And then I go and detect it. What are the tools that I use? It's very descriptive. So if I look back at the example that I gave off the top for ethics, we have a very descriptive statement being given about the world and how we can predict how technology is going to be adopted. And then we have the ethics jumping in and saying, well, here's how I want to modify that, and say something about whether that is a good way of approaching the problem here. We need to add this additional normative consideration in order to get to the right way of doing it, or the most responsible way of doing it. It should move at the speed of trustworthiness. We should not be giving people technology and asking them to use it if it's untrustworthy. And then, of course, maybe it is untrustworthy. We have to look into that. Okay, what's the currency of ethics? The way I describe it, it's arguments and justifications. And again, this is, if I'm contrasting that with how I was taught to do engineering, it's very different. So what's maybe the argument that I'm making here about the AI? Well, it's something like this. We often think a technology is capable of more than it's actually capable of. We over-trust it. So you might use a Tesla autopilot, which is like a classic example of that. It's becoming a classic example these days. If we over-trust technology, we leave ourselves open to harms, right? You can get into crashes in a car if you're over-trusting the automation. We can also under-trust a technology that's more trustworthy. Like, we may be missing out on benefits of that technology if we under-trust it. So it's important to calibrate our trust of a technology to its trustworthiness. And again, we can get into arguments about whether or not it's like we're actually capable of trusting a technology, or if it's like just things that happen between two people, whatever. We talk about technology this way. And so I'll just use it this way, like as a rough estimation, that there's something to be said about trustworthiness, the trustworthiness of technology, and using it to calibrate our trust in the technology. So to be prudent, we ought to adopt technology only insofar as it's trustworthy. There's the full argument, right? And this is the currency of ethics and philosophy, right? Like making good arguments. Let's shift over now. What's engineering? I've got fewer slides for this. It's the study and application of science, hugely controversial. Study and application of science, math, and design to solve problems created by technology. For example, structures, machines, and devices. You can also engineer physical systems or processes, right? This is a controversial statement, the application of science part. When I started my engineering degree at Queen's, were the Faculty of Applied Science. And they were holding a referendum on whether or not we should change the name to the Faculty of Engineering, or I think there was a third one I didn't understand, coming out of high school, I had no idea why people were arguing about this. I kind of get it now. Is it just the direct application of science? We can talk about that. Maybe it's not, maybe it's something more than that. It's definitely the making of tools to build or improve other tools. I think it is. That's how I see engineering. It's like tool use. It's also a regulated profession, so there's a legal aspect to it in Canada, at least. Okay. One of the models that we use in engineering to understand what technology is and kind of how it fits in society, the stuff that we're creating, is this kind of technological solutionism model. Society has problems. We sort of like inherit those problems as engineers or recognize those problems. We create some technology and then we solve that problem and then we're done. This is an oversimplification. You can ask, is engineering just problem solving? And to get at the answer to that question, you just kind of ask yourself, like, what is technology? These are questions I started asking myself pretty early on when I went back to study philosophy, having just come from the world of engineering. Like, what is this stuff I'm building? Like, how does it fit in the world? Like, why do we build this and not that other thing? Who makes decisions about this? It was fascinating to me, and this was kind of the philosophy of it all. But what is technology? Well, technology is not just problem-solving stuff. It's something that redistributes political power. So here we have automated drones or drones of some sort. This is not necessarily automated. And then X, the former Twitter, right? Really acting to redistribute political power in the world. Technology creates whole new possibilities for action and eliminates others, right? Airplanes changed the way that we think about transportation. Got us off the ground for the first time, really changed our perception of space and time. And prisons and these kinds of technologies eliminate certain types of action, like have implications for freedom and other things like that. Technology changes the relationship we have with our own bodies and forces us to redefine core concepts like death. Like what is death? For those of you who've taken bioethics, this is like one of the core topics in all the bioethics textbooks, like the first year bioethics or undergraduate bioethics. Fascinating stuff. Who thought that technology could do that? From one day to the next, you've got to rethink the concept of death. That's powerful. And it just fundamentally disrupts norms. We're seeing that more and more. And what I mean by norms, like norms of all kinds. Laws, just kind of like social norms. ChatGPT, if you think about it, the impacts that it's having in our classrooms, especially as philosophers. Right now, it's encroaching on kind of like persuasive argumentation. Real problem. How many of you are just like struggling to grapple with ChatGPT in the classroom, just by show of hands? Some of you have figured it out. I only saw how. I really want to get into that in the discussion. I need your advice. So the way that I've represented technology here really focuses on how socio-technical technology is. You can't analyze technology just as like a thing that solves problems. It's deeply embedded in society. It changes the relationships that we have with ourselves, with other people, with society, with the physical world. And so this is kind of a picture that I use to think about our socio-technical reality. Technology is in the mix. It is linked to a whole web of actors, the public or publics, governments, kind of norms and culture that we have and expectations around that, the courts, so institutions, people, practices, industry and engineering. And if it's a solution to what and for whom, right? Multiple legitimate competing interests will end up shaping technology, and technology kind of co-shapes those interests. It's difficult to prioritize who should come out on the top, like whose interests get prioritized. We require multiple expertise, like from law, ethics, science, engineering, policy, to kind of grapple with the fact that we're developing certain types of technologies. And the solutions that we come up with are very unstable. So this is, I mean, for those of us who study ethics, this is why we have a list like this, and it's growing all the time, of just, for example, topics in the ethics of AI. When I started teaching, it was a course that I called Robot Ethics at the time. This was at Carleton when I was a PhD student. It was sort of 2010, I'm thinking, was the first time I taught it. You couldn't find a textbook on ethics of robotics or ethics of AI. In fact, no, I didn't talk about AI because nobody was talking about AI at the time. It just wasn't a topic of interest, right? Like there were no courses that you could take. It was one of the early courses. I co-developed it with a law professor at the University of Ottawa. And I taught kind of like the philosophy ethics version, and he taught the law ethics version of it. But these topics were not even on people's radars back then. And now we see, as the technology has evolved and kind of found its way into multiple, like AI has found its way into multiple different technologies and different parts of society, and now everywhere, the list is growing. But it's like very, kind of speaks to the socio-technical reality of technology. Another way of thinking about ethics that I've found, or engineering, the relationship between technology and and ethics, is to think of it as this: engineering is doing ethics by other means. So this is Peter Paul Verbeek, somebody who I found very useful in my PhD. When you engineer things, you are always making decisions that have like ethical implications of some sort. So the idea that you can do engineering in a kind of neutral way, like value neutral way, is just a fiction that we hear all the time, but it's a fiction. And so you can say, well, engineers, what do? Well, they also mediate and shape human and non-human activity every day. Unfortunately, and here's one of the generalizations I'll make, it's most often without analyzing or mitigating the negative socio-technical impacts of their work. And I mean from this broad, long list of socio-technical impacts. Engineers are very good at some topics because they've internalized those things. Safety is one of those topics that, like, for example, if you go into the aerospace industry and look around, people are very concerned about safety. They've internalized it, but it wasn't always the case. It took something to change that. We're getting a little bit of traction on engineering or on environmental ethics over the years, getting better at that. Again, it took decades to shift that way of thinking about what engineering is and which types of harms we're going to internalize in engineering and turn into regular practice. We certainly have not done that for the vast majority of AI-related harms that we're identifying. And so there's a lot of work to be done there. And again, like shifting over into the normative claim here, they should be analyzing and mitigating those harms before they put technology out in the world. But that's controversial, right? That's not, like, when you say that, you're saying something controversial because you're saying that a whole field needs to change the way that it works. And that's what we'll get into in the next little section. So the story so far. So I just want to step back and recap. Why am I talking about ethics and engineering? So changing the way technology is designed can help to mitigate technological harms. Like, we need more ethical tech design. That's my claim. Engineers are experts in making technology, but they're not experts in ethics. So it's important to just make that clear. Engineers don't study ethics. They're not experts in ethics. There's engineering ethics, but I can tell you it's not what we're talking about in philosophy classes. And ethicists are experts in socio-technical analysis, ethical analysis, kind of normative stuff. But they're not experts in tech design, nor should they be. We shouldn't expect either of those fields to become experts in the other one's field. This just doesn't make any sense. So how do we get more ethical tech design then? This creates a problem, right? We make these demands of engineers and engineers push back. So how do we, what's the secret here? Well, how can we fix this? There are a few candidate methods that I've seen used, that I've tried myself over the years. Excuse me. The first is teach engineers ethics. when I was doing my postdoc, I was at a Center for Ethics in Society at Stanford, and I was working with an engineering group there. And the director of the group in the ethics group, I was starting to develop some of these things. Like this was maybe 7, 8 years ago, and I already realized that like the first thing doesn't work. It's not efficient. It doesn't change. Like you can teach engineers ethics and they're interested. There's nothing wrong with that. But it doesn't get them changing the way that they design technology. It doesn't just happen because there's a whole socialization that's missing there that has to do with the way engineers take up their work and do their work in practice. So this director at that Center of Ethics used to say to me, like, Jason, just be a philosopher. Just go and teach them ethics. And I used to always say to him, like, no, Rob, that doesn't work. Like this, we need something else, and we need to figure out something else because they like it, but they don't know what to do with it. The other thing is just to sort of like lob grenades over the wall, like tell them what they're doing wrong, and then like they'll just feel bad about it or something like that, and then they'll change what they're doing. It also doesn't work. We do that all the time. I do that all the time. It doesn't work. We can specify ethical principles. I think that's the latest push that we saw, say 2016, 2017. We saw this explosion specifically with AI principles. I think in a year there were probably like 50 or 60 reports put out by different organizations, big companies, about all the ethical principles that they were developing to help guide their design. And what we've seen happen since then is very little of that getting into practice. Why? It's this translation problem that you have to do to go from a principle that comes from this other domain. Like, you know, if you're an engineer or a computer scientist designing some model that's going to do facial recognition, and somebody tells you that you need to eliminate bias, like you don't know what bias is, you don't know what kinds of bias you're looking for, you're not an expert in that field, you're not sensitive to the kind of like ethical issues that are hidden, but like that are packed into that word. So what do? You just ask somebody like, what sort of bias am I supposed to be looking for? Is there a tool for that? And then if somebody gives you a tool, you use it. But you don't really necessarily think much about the bias, right? It's not what you do as an engineer. Then there's this last one, and that's what I want to talk about. Develop interactional expertise. So that's where I'm gonna dive in now. This comes from science and technology studies, mostly Collins and Evans and related work. And this is about developing a new expertise that blends engineering and ethics together, like fundamentally changes it. So, but I want to talk about what prevents the first three things from happening, like from working. Teach ethics, tell engineers what they're doing wrong, and specify ethical principles. There's a little bit of theory behind this, so I'll get into a little bit of the theory. It's something like this. So this comes from STS mostly. We get socialized into our professional frames. Engineers do their work in a particular way. Ethicists do their work in a particular way. What does that mean? It means that you're asking questions. You have certain values that are specific to your discipline. You kind of carve the world up into different like subunits in different disciplines, and like your unit of analysis is different from someone else's. You know, in ethics, you're using norms and arguments, and in engineering, you're maybe using like math and tools, like computer programs or something like that. And there's this line down the middle, and this is what we talk about when we say silos, right? There are these disciplinary silos. We're all probably familiar with this talk. The goal here is to overcome that, to perforate that wall, like to have some sharing going on in between, so that you develop this thing called interactional expertise, which isn't like deep expertise in another field, but it's enough expertise that allows you to contribute meaningfully to the work that they do. I'll let that sink in for a second. So interactional expertise is the goal, and the whole point of interactional expertise is to have just enough expertise, there's a whole literature on this, just enough expertise that you can contribute meaningfully to the work that's going on in that other domain. So it's like you can, like what I do, I try to contribute to philosophy, contribute to engineering functioning as if I'm thinking as an engineer, I want to contribute to philosophy. That's kind of what I'm doing today, actually. Today is my trying to exert my knowledge of my interactional expertise, from engineering to ethics, I think. Although I guess I'm a philosopher, so it doesn't quite work that way, but anyway. So what's the hallmarks of interactional expertise? You can see this, you can hear it, you can feel it when you're in the room and it's happening. There are these kind of emergent properties that I'll talk about. You know it when you start developing a common language that's not quite the same as your disciplinary language that you've been using before. It might sound similar, but there's something subtly different about it. You develop shared goals and values as a new kind of overlapping discipline. You start developing common tools. That's concepts, frameworks, methods, the stuff that you use to do the work. And in our case, we're going to talk about a new design practice. You're talking about building tech literacy, and this involves working together, being in the room with one another, having conversations to merge ethical and engineering concepts and practice, and co-develop all of these things. I'm going to use a metaphor to explain what I'm talking about here, just to kind of get us out of the technical talk. So this is like a mashup. So if you've ever done kind of mashups or talked about mashups in art, mashups are things that you can use to kind of to try to foster creativity and practice. And so I'm going to talk about a mashup. What's a mashup? Well, okay. So we're going to play a game. I'm going to start to show you the elements from different domains that got mashed together to produce something new, which is a kind of example of what I'm talking about. So here we go. The game is name that mashup, or name the mashup. So first, here we have greasers from the 50s, right? This kind of aesthetic, the kind of anti-hero, the James Dean anti-hero, right? Rebel without a cause. You've got the leather jackets, the jeans, the belts, the t-shirts, that kind of thing, the hair. Mashed up with the kind of hippie aesthetic from the 70s, the hairdos, the glasses. Mashed with the sensibility and style of and the frenetic energy of some rock and roll from the 50s. High energy, kind of breaking out of the traditional standing still in front of a microphone. Mashed together with, for those of you who play guitar, the power chord. You've got 6 strings on a guitar, you only need 3, and you only need to have your fingers in that position on anywhere on the guitar neck, and you've got a power chord. Simplifying. Mashed together with using breaking taboos in lyrics. Can anyone guess what I'm talking about? I've never done this before, so I don't know if it's going to work.
Is it metal?
Oh yeah, it's close to metal, but metal's a little bit there's a technicality to metal, like fast, yeah, so close. Anyone else? I think I heard someone say it. Punk. Yeah, this is the Ramones. Right? So we can have an argument about whether they're the first punk band or not. I'm just going to plant my flag and say yes. But the Ramones, look, the Ramones are a classic mashup. It's creating a whole new thing, which is, it would be difficult to argue that punk was just like some other music out there. It's very different. It's got a different aesthetic. It's got a different sound. Technically, it's different. The whole, all the lyrics are different. It was very controversial and disruptive. It was a new genre. It democratized rock and roll. That idea of just playing 3 strings at any given time. You can even do power chords with 2 strings. You can simplify it even more. Makes it very easy for anybody to just go grab a guitar and immediately start writing songs. And it was hugely influential. Okay, so that's a fun example of a mashup, but it's very very similar to other mashups. I look at clinical ethics and I see the same thing. This is an example of interactional expertise. So this is kind of where I started really thinking about this way of applying applying ethics and philosophy to engineering as a practice, which we don't do. And the model that I used was clinical ethics, a great mashup, a great example of interactional expertise. So why? It combines philosophy and ethics with healthcare, medicine, nursing, et cetera, the kind of, the various professions. It relies heavily on interactional expertise for its success. It was controversial, disruptive. The gains that what we would call gains as ethicists, I hope, were hard-won gains. Like we were fighting, well, not me, but those who really pioneered bioethics were fighting against very powerful interests, doctors, nurses, and demanding a change in practice. It addresses practical ethical issues in healthcare with actionable solutions. So it's very practical, it's like, I call it bioethics at the bedside. That's how I understand it. Clinical ethics is like in the hospital. It's not in the philosophy department. But it also lives in the philosophy department, right? That's why I got into this, doing these clinical ethics rotations. And it results in changes in law and practice among regulated professions. It established new norms in healthcare, and now it's well established in law and in practice. Still controversial, a lot of controversy, but it makes it makes change, right? So this is what interactional expertise does. This is a good model of a mashup that produced interactional expertise that was based on interactional expertise that made changes, right? And where did that come from? Philosophy and ethics specifically. Okay, let's get into part 2 now. Looking at the time. Okay, ethics modeling. Now I'm going to get into talking. I've done the setup now, right? Like talk about interactional expertise, what we need to do to change practice, what's ethics, what's technology, what's the goal here and the problem, like changing design as a practice that is currently owned by engineers who are like physicians, very powerful group, regulated profession, long history of doing their own things. And we're trying to change that. Well, I am anyway. And I hope that someday you too will try to change that. That's one of my goals. Okay, so what is ethics modeling? It's a mashup between ethics and engineering. I've already this should be no surprise. What we're doing here is we're combining core ethical practices, right? So the focus on normative consideration, an emphasis on the currency of argumentation and robust justifications, doing ethics, doing applied ethics. We're going to combine that with engineering design, which is very focused on processes, checklists, development and application of tools, the need for action in uncertainty. So it has a lot in common with like medicine in that respect. And we're also going to use engineering techniques here. So we're going to borrow, almost like smuggle in the term modeling to make it sound like engineering. That's it. It's a modeling technique. Why do I choose the term modeling? It sounds very engineering. So let's do some ethics modeling. Let's draw a diagram. Here's ethics modeling in a nutshell. This is the diagram. First, like version 1, we'll call this. So see what's going on here. I'm going to use this now. Since there's a diagram, I'm going to use the laser pointer. Very engineering. So here we have the ethics model, lives in the center of this, let's call it a design process, ethics modeling. We have model inputs. So for example, principles or laws, right? Those are kind of, you can think of those as things that are going to guide or constrain our modeling process. And what we want to do is we want to model a piece of technology, which is right over here, but we want to model the technology in a particular social context. Technology always lives in a context. There's no AI. There's ChatGPT in the classroom. There's that model doing facial recognition at the border, right? There's, like, you see what I mean? There's like, you have to get away from the abstractions now. We're in the applied, like at the bedside, like applied ethics in the design room now. So what's the context? What's the use case for that technology? We're going to perform an ethics analysis. What does that mean? Well, it's got a scope. The scope is that we're going to always consider technology socio-technical in nature to get at its to make sure that we can do a good job of analyzing it. It's going to be norms focused, right? It's an ethics analysis, so it's going to be norms focused, right? But norms here will play a special role. We're going to focus on the norms as like a unit of analysis. We'll call it a unit of analysis, very engineering. And then we're going to apply ethics modeling tools. We're going to build some tools to help us get the work done and to help bring it into that engineering context. And then there are going to be technological aspects that we need to take into consideration. So for example, if you're doing this for AI, you need to understand like what kind of a model you're talking about. Is it an LLM? Is it like some sort of regression model or something like that? Very different kinds of models. So then this is the interactional expertise kicking in, right? Like to do ethics modeling, you do have to have a little bit of that crossover understanding of like the technology. You can't just like lob the grenades over the wall. You have to get a little closer to the practice. So this is what I was talking about when I was showing those diagrams about interactional expertise, right? This is so there's a lot of interactional expertise going on in here. And then once you do your analysis, out comes some outputs, some model outputs. So the ethics model is going to describe the normative aspects of the technology in a given social context. And then you're going to spit out things that really feed into tech design. You can spit out design requirements, which are essentially like normative constraints, like you should or shouldn't do this. And it's going to feel very familiar to you as ethicists. It's just going to be framed in this modeling exercise. And then you're going to demand justifications or arguments. And then this fits into an engineering process, just like mechanical design, electrical design, where they have their own kind of inputs, constraints, they do their own kind of modeling, and then they spit out requirements from their design exercises, and it helps to guide the design of technology. But this is formalized in a way that is like, it's meant to provide that crossover, that interdisciplinarity, that interactional expertise. Okay, so there's a basic methodology. Again, this is like version 1.0. You identify the model inputs. This is like thinking back to that picture I just had. You define the socio-technical scope, so the technology plus social context. So for example, ChatGPT in the classroom. You do your ethics analysis. And what does that mean? That means you act like a philosopher, like an ethicist. You look to the literature. You do some research. Has anyone thought about this kind of technology before? Is there another technology or ethical argument or like some other context that I can use to bring it into this context to really start thinking about like what are the norms that apply to this new technology or this new context, right? So it's a lot of like argument by analogy. So for example, you might and you can use metaphors. There's like a tool that I've developed called metaphor hacking. There's another tool called social failure mode analysis. Again, like you'll see the engineering stuff here, like failure mode analysis. But social, what's that? Well, that's the ethics part. Hacking, but metaphor hacking, what does that mean? Well, that's like thinking of like this, you bring a metaphor like a tutor in to describe what you want ChatGPT to function like in an education context, then the norms pop out. Well, what does a tutor do? Supports learning, provides additional explanations, like prevents cheating, things like that, right? Like a tutor is gonna support you in your learning, not allow you to just like hammer out an essay in 30 seconds and then submit it without having really thought about what you're submitting. So you're going to apply some of these tools to do the analysis. You're going to acknowledge some of the technological constraints. Again, so what is possible given the current state of the art of the technology? That's like your interactional expertise with engineering. And then you generate the design outputs. There's really no, hold on a second, I've lost my, okay. Yeah, there's no magic here. It's just like really doing the work to translate what we could do with ethics in a more formalized way in an engineering context that really takes into account the needs of engineering and the needs of ethics, like again, like focusing on norms and robust justifications as like the kind of currency of applied ethics. Okay, let me give you an example of what I'm talking about here. Okay, the example I'm going to use is autonomous vehicles. So this is like the first chapter of my dissertation. Again, if you read this paper, it's not about ethics modeling, but I'm doing ethics modeling in this paper. This is not how I talked about it back then. Okay, so think back to all the talk about autonomous vehicles 10 years ago. Fun times. Trolley problems. You all know what I'm talking about in a class full of philosophers, or in a room full of philosophers. Question I was interested in as an engineer, as somebody who saw all the conversation happening about trolley problems. It's like, who has the moral authority to make these decisions? As somebody, well, having talked about bioethics and all this stuff, like you can almost anticipate where I'm going to go here. But who's got the moral authority to make this kind of decision on behalf of the pedestrians or the people in the car or the other people in the other car? You remember all these versions of the trolley problems, right? There are babies, old people, people in other cars, cyclists, you name it. They've come up with every iteration that you can imagine. Is it engineers who have the moral authority, or are the passengers or passengers/driver, depending on how you conceptualize their role in a driverless vehicle? Is it the standards associations like the IEEE or some other engineering standard organization? Is it society? Like, do we need to look to regulators and like go through some democratic process? I can tell you that when I was working on this in 2014, the assumption unstated was that engineers had the authority to make that decision. What we needed to do was kind of like run some experiments to figure out like how they should program the cars. And so some of the ways that they were doing that were like public surveys, like who do you think should die? Like the old person or the young person? If you've ever come across The Moral Machine, you may remember the absurdity of that experiment. And why? Well, as ethicists, like you understand at first, like, well, there's a problem with taking a poll and using that as the right thing, like as a proxy for the right thing to do. Again, this is ethics coming to bear on like a very engineering way of solving a problem. Like, hey, let's do some user studies and figure out what people like the most, and then we'll just do that. It seems like that would be the right thing to do. How do we solve this problem? In the paper, I also use internal cardiac defibrillators, ICDs, as an example. I actually thought that was the example that people would latch onto. It turned out it was the autonomous vehicles. Surprise. At the time. So let's run through this. Okay, so what are the model inputs here? At the time, there were no clearly defined principles or anything like that. Basically, like legality, like the car has to like obey the law. But there were no clearly defined principles. So thinking back to that block diagram, there's nothing for engineers to work from in order to start answering that question. So we needed to find that through the analysis. That's why in the block diagram, I have like a feedback. Like sometimes it's very iterative doing the ethics modeling. What's the socio-technical scope? Well, in this case, it's autonomous vehicles making life and death decisions. So these trolley problems, pick a trolley problem. Let's use that as an example. I came up with one called the tunnel problem for very specific reasons in my dissertation, but the kind of meat of the analysis was from bioethics. So I thought, well, you know, there are other circumstances in which we have highly trained experts who used to make decisions on behalf of other people, life and death decisions, kind of like not trolley problems per se, but like whether to do a surgery or whatever. They're called doctors, right? Like doctors, like 100 years ago, used to just do what they wanted. They were the experts, and patients didn't really have any say in the matter. So engineers in this case are kind of functioning like, this is the metaphor, right? This is where the analysis comes in. It's imperfect, but it's the way you go through it. Like medical experts, so there's the metaphor. Passengers are a little bit like patients in this case. They're subject to those experts' decision-making when using the technology. And so you can model the technology as a moral proxy, what I called a technological moral proxy. And I developed this kind of concept of using metaphors to do this work. I call it metaphor hacking. Again, it's a tool that you can use to do some of the work in ethics modeling, like to do the ethics analysis part. But here, what I will say is like the car roughly functions like a moral proxy. Like it's weird because it's not the person, it's not the engineer, but the engineer's kind of, the car's essentially working on behalf of the engineer in this case, not the person in the car, because the engineer is the one that programs. If the engineer's got the moral authority, then if they've made the programming choice, then they're making the decision on behalf of the person in the car, right? And that sort of starts looking like, so then we can draw some principles from bioethics as well to start understanding like, well, is that the right way to do that? Like when we have a moral proxy, there are ways that we, define what's permissible and impermissible in terms of like what kinds of decisions you can make on behalf of others. So the argument that I made was roughly that like, well, in the case of healthcare, like patient autonomy prevents healthcare experts from making these kind of decisions. This concept of a moral proxy, like a moral proxy when they're acting, when they're making decisions, are supposed to make decisions in the best interest of the patients. And there's a whole way of sort of figuring out what that looks like. And so we're really leaning on like concepts like paternalism and autonomy to understand like how to work through the design problem here. And so we can establish some normative design considerations, again, from bioethics, again, like just sort of following this through to its logical conclusion and trying to make sense of like who among those list of potential people or groups have the moral authority to make these decisions. Most likely not engineers, which is the interesting finding, I think, because that's the assumption that was the working assumption in 2014. Now there are these other potential actors, actors who potentially have the moral authority. It's going to start depending, like it's more complicated than that. Also a thing that philosophers say that drives engineers crazy. Well, it's complicated. But that's technology. You've made this technology that is doing this thing that is very morally complicated. So standards associations, maybe. The yellow is like, red, yellow, green. It depends on the process that you're using. I suppose it's going to lack some legitimacy, like sort of political legitimacy. The processes can be like very biased towards corporations and things like that. So like there's some problems there. Passengers, this in my mind flips between green and yellow depending on the context, the specific context that you're talking about and the type of decision. So if it's like high stakes, like life and death decision making, maybe not. If it's like the passenger but no other people involved, then maybe the passenger should be given the say in that. Now, just practical problems, how do you do that? Like, I get it. I've had those conversations, but the moral authority question doesn't shift based on what's possible technically necessarily, right? And then society. Well, this seems like a good candidate because it promotes transparency and legitimacy and, promotes autonomy as well, so that people can make choices about what kinds of technology they participate in. Okay, I've got a couple minutes left. I think I can do this. Yeah, I'm close. Okay, so the model outputs here. So what do we output at the end? Well, you can come up with some normative constraints on the design, right? So here's where you actually start getting into what I would describe more like high-level design, like ethical design requirements, and those are very engineering. That's the link. That's like the direct interface between the ethics analysis and what engineers do every day. You give them a requirement, they design per the requirement. So here you're like you're feeding right into the process that they're familiar with. So engineers should not be making life and death decisions on behalf of drivers, passengers, and other road users. External consultation with regulators is needed. So again, it's a way of like making arguments to pump the brakes on, no pun intended, on certain types of technology by virtue of not having the right type, like the correct kind of ethical guidelines in place or decision making in place, legitimacy maybe. Where control decisions, and I mean like control, like whether the car goes this way or that, where they must be programmed. So in the absence of regulatory clarity, because like it can take a long time for regulations to happen, they should be made transparent to promote autonomy and fairness among all road users, because it's like not just the person in the car, it's other people. And then I say like consider the use of ethics settings in the vehicle to capture some of the driver preferences if permissible. Again, this is like bumping right up against like engineering design, like settings in vehicles. Like, and you can define what the settings look like and so on and so forth. The other benefit here is that it feeds some principles back to the beginning of the loop, so you can do another iteration or test out these principles. Where we had no guiding principles before, and now we have some guiding principles, right? We need to think about autonomy, fairness, justice, transparency, legitimacy, like in order to design that type of technology. Okay, we're at the very end here. These are the takeaways. So think back. Our goal was to get to a point where we've got this kind of thing going on. Now, if I give this talk in front of a group of engineers, I'm getting much closer to this now than if I just came in and started talking about autonomy and you shouldn't be doing this. And like, it's a subtle shift. It almost seems like it's ridiculous. All you've done is taken ethics and put it in a diagram and kind of like talked about it as modeling. What can I say? It's like recognizing the way that engineering gets done and formalizing it in a way that is meaningful, and it makes it familiar, and it gets people to ask like, explain that to me, instead of like, that was interesting, and then walk out of the room. I've done both. It builds this interactional expertise. So I will describe ethics modeling as a new design expertise. It borrows from other types of design, but it avoids these kind of ineffective and insufficient alternative methods for changing design for the better. The three candidates that I talked about that don't work, or that are just like hard, it doesn't necessarily work. They're not sufficient to create change. It creates a new shared, what I refer to as transdisciplinary language that combines core concepts from both ethics and engineering. It definitely bridges those worlds. It dissolves disciplinary silos, or at least like creates that porous interface rather than a hard line between the silos. It does emphasize processes and tools, repeatability and efficiency, which is like very much like what you want to do in engineering, is how engineers work. These are things that they need to get their job done. It's not an optional thing, right? And it provides a very practical and critical method for translating between high-level design inputs, like principles and laws, and design decisions. And that gap was empty, and it still is mostly empty when you talk about how do you get from all those principles, for example, in AI, all the AI principles that were developed 2015, 2016, 2017, up until, I don't know, maybe 2018, 19. How do you get people to actually implement those in a way that would satisfy the ethicist as critic who understands that term, like justice, fairness, bias, deception, whatever it is? This provides the middle part, the missing middle part of that design process. And here's what I think is just like, as a philosopher, so exciting, is that like all of this comes from philosophy. This is the result of a philosophy PhD, not an interdisciplinary PhD. ethics expertise is at the core of ethics modeling. This is not, you know, it's not ethics light. It's like, it's applied ethics of technology, is how I'll describe it. Focused on design, like this whole area of design that we could get into. There's loads of research that needs to be done to develop this kind of a field. We need to develop the tools, we need to develop the kind of core conceptual thinking around different issues like, you know, like deception in like again, applied ethics. Like imagine the applied ethics papers that you read, like, you know, should AI agents be able to deceive people? What is it, like, is it morally permissible to allow like 10-year-olds to get into emotional relationships with an AI chatbot? Like these are core questions that we need to think about in order to drive that design process. And also figure out like what we can bring into that ethical analysis piece. And more importantly, which I think I don't want to leave without saying this, is that like this work emphasizes the critical importance of knowledge from like what you would call maybe more traditional philosophy subfields like normative ethics, epistemology, philosophy of mind, ancient philosophy. I borrow from all of these in my work. And if that's not moving forward, we run out of, it's like the tap runs dry, right? Like you take these fundamental kind of foundational, more like sort of theoretical ideas and apply them. That's why it's applied ethics, it's applied philosophy. I think that's critically important. And I'll end there, and I'll open it up to Q&A. I'm very excited about the Q&A. So I know that I think there's a microphone in the room, and then I think possibly also questions online. So I don't know how you're going to field that, but I'll just take cues from whoever's got that.
There we go.
Great.
Just to note to anyone joining us online, if you have any questions, pop those into the chat. I will do my best to read those out. Those of you here in the space, just raise your hand. I'll run a microphone over to you. I see a hand over here.
Thank you for the presentation. I had a question about your view on economic incentives being a potential barrier to this kind of thing. So for instance, this kind of work requires slowing down, deliberating things, looking at it from multiple perspectives, entertaining doubt. And then if you're out in industry, like let's say if you're a venture-backed organization that's developing a piece of emerging technology, it's all about going fast, going through any kind of resistance, not necessarily being interested or receptive to entertaining doubt. Yeah, it seems like there's like a number of barriers that seem to be getting in the way of applying this.
There are so many like structural barriers, right? Institutional barriers. There are just so many. I guess I have a lot to say about that. This is one prong of a multi-pronged project that we all should, like, I think we all need to be participating in to really change the way that technology gets designed and deployed in society, right? We've seen it happen before. So yes, this is just the latest version of, you'll hear things like stifling innovation, slowing down progress, like all these kind of things that people just reflexively, the way that they reflexively respond to these kinds of concerns. And, to be blunt, like if you look back through history at how these types of changes come into effect, it takes a lot of work. It takes a lot of resistance. It takes a lot of cooperation, and so resisting like the worst, most egregious kind of examples of technology. But it takes time. So, one of the things we're doing at like the University of Ottawa, we're trying to start a project up to like get to teach engineers. Like so let me back up a little bit more even. When I talk to engineering students, they are very receptive to this kind of thing. Something happens between like first year engineering and like 3 years into the job at wherever. And it's a socialization, right? So what we're trying to do is give engineering students the socialization and the tools to act against those existing structures that would prevent them from doing this. One of the things that prevents the change from happening is that we're talking over or past engineers many times, right? We're doing one of those first three things. Like we seem like we're complaining, which we're not. We're making arguments, rational arguments about things that shouldn't be happening. So again, like I said, I could talk all night about this because I've been living this for a long time now. So one of the things we're trying to do is make a change. This is just one prong of a many-pronged approach that needs to happen to really change what's going on in practice. But one thing is like socializing young engineering students, right? Giving them tools to engage in policy making, which they are never taught about. Changing curriculum so that they're given these kinds of tools. They understand that there's a way of doing this that works. I mean, one of the reasons that I titled the talk what I did was that I'm very interested in getting philosophy departments to think differently about how they approach applied ethics curriculum, specifically around robotics and AI and other emerging technologies, so that we can start building that capacity in where I think it just is such a critical core knowledge domain, which is ethics, applied ethics. And developing the arguments. It takes time, it takes numbers, like you can't have like a few people here and there, but change can happen. Like we've seen it happen with environmental practice, things like sustainability. Again, like nothing's perfect, right? Like we haven't solved environmental problems, but we've made progress, we have. Safety in the auto industry, in aviation, in consumer products, we've made a lot of progress over the years by introducing different concepts of safety and getting them internalized. But I guess what I'm saying with this approach is that I believe, like in my experience, what I've seen with in practice and what the literature suggests is that this is a more efficient, effective way, or it's like than those other three. So it's worth giving it a shot and adding this to the mix so that we can, do design for a number of different values, not just safety or whatever, but like all of them, right? We can start developing methods for changing design and doing it in concert with engineers rather than in resistance in a way that, over time, hopefully will change practice. One of the things I want to do is like more history reading on like the history of bioethics in the 20th century, because however it happened there, I mean, you're talking about significant political interests that shifted. They shifted because, I'm assuming, you have to believe it's because people recognized the need for change and they fought for it, right? And I think we can do the same with this. So that's my long answer to a very good question. And it's only a partial answer. I get that. Yeah. When there are, $400 billion being put into AI development, it's hard to tell people to slow down a little bit. And we've seen how they've kind of stopped paying attention to the ethics to try to get first to market. It's very frustrating, but that's just that's the landscape we're dealing with.
We had another question right here. May I jump again?
All right. Thank you so much for the talk. Really interesting. But let me try to as we're trying to push back against the model from a more philosopher's perspective, I think, and say why one might think that it's actually hard to do this in principle, even, as it were, to marry the ethicist and the engineer. And here's what I have in mind. I have two things in mind. First, ethics seems complicated, maybe even chaotic, and that means it's hard to come up with outputs for the ethics model. And the second thing is that maybe there's a difference of way of thinking that goes deep. Let me illustrate both of these points. The first one, ethics is complicated. If we take your example with the self-driving car, right? So I have a car, a person is standing in front of the car, someone is sitting inside the car, even though the car it has certain automation. Person inside the car puts the pedal to the floor to run over that other person. Should they be allowed to, should the car intervene or not? Say no. Okay, but what if the person on the street is pointing a rifle at the person in the car? It's self-defense. Okay, but hang on, the person with the rifle is actually a prison guard, and the person in the car is trying to escape from that prison. But hang on, the whole prison is inside an unjust state, and the person in the car is actually a freedom fighter unjustly imprisoned. And I could go on, and every time the situation flips, right? Every time is it where you have a different intuition about this. And so I'm a bit close to despair when I'm thinking, could I model that into a self-driving car in any way? I'm just like, I find it hard to believe that something like that is even possible. So that's point one.
Yeah.
Okay, it's about chaotic, or maybe at least very complex, depending on where you sit on.
I feel like I need to write this down too. But go on. Yeah.
And the second point is the difference in way of thinking. And there I'm thinking one thing that engineering, I think, tends to do to you, both in creating tools and also in using tools, is to think instrumentally, right? To think in terms of a goal. You have a goal and you want to pursue the goal in an efficient, mean way, usually. And that's what engineering is great at, right? You give an engineer a goal, and you give them specification, and then they do something, and then you get that done. That's the great thing about it. But then there are certain things where you think, maybe that's not the right attitude to have. I don't know. Maybe it would be a very efficient way to say I'm sorry to people by having a machine do it for me. But it would be it seems to be not the kind of job that you want to get done efficiently. It seems that the whole idea of instrumental reasoning seems to be out of place in that situation. So there seems to be a question: isn't there a certain kind of orientation in the thinking of an engineering mindset in tool use, built into the tool use in a certain way that we want to keep at bay, as it were, in a principled way, and not marry with the...
Yeah, so let me, maybe this answer, so I take your point. And again, this is, I think, the power of philosophy. I'll start with that. Like what we're so good at is thinking through all of these, scenarios, counterfactuals, to try to get to a place where we've decided, what should we do here, right? One of the things that I think strikes me about when you're functioning in an applied, like a very applied, like clinical ethics domain, like all the same kind of things come up in healthcare, right? These really thorny, difficult hypotheticals that you can come up with when you're trying to develop policy or something like that. But when you're operating in a domain where things you need to act in uncertain circumstances, what I'll say is that it's better to have that ethicist thinking through those things, even if you're, because they're guiding the decision making, right? So yes, you're not going to be able to cover, this is the other thing about engineering. It's like you've never got things perfect. You've got deadlines and then you get things done. I would rather have some of that thinking in there to guide some of the good decision making, to flag cases where we really don't understand whether this is permissible or not, and we're really worried about something, but maybe not so much the passenger or the person on the street, maybe it's a prison guard. Right? So maybe we can abstract away and say, look, we can't solve all these problems, but what we can do is guide the most problematic cases into a better place, right? And maybe there you're, again, it's all there, this is, so I take comfort in seeing that we do have a very positive, ethics can have a very positive impact in these contexts where you have to act. You don't have, the decision needs to be made by Thursday, right? And you can provide the input. It's never perfect. That's not what we're striving for in that context, but then you can support it with that deeper, slower thinking that eventually will lead to better decisions overall. That's the model here, right? It's never, so that I think that answers your first question, that sort of paralysis of action problem, right? Because you just have to act. I mean, and it gets done. It gets done in healthcare, it gets done in other engineering contexts. And it's never perfect. I think the second, I want to say that I think it maybe partially answers your second concern, which is that we can learn something from that. When you, it's amazing to have the luxury of not, of just being able to think slow and contemplate, right? We don't see that enough in this world right now. Fast thinking is everywhere. So, but there's something interesting about marrying those two worlds and seeing what comes of it. And if it's guided, I guess maybe I have faith in ethics' ability and philosophy's ability to guide in the right direction. It's certainly what got me, what I fell in love with the discipline in the first place. So I'm an optimist in that way. So maybe I don't share the same concerns. I'm also an engineer and so I kind of work in that headspace anyway. I'm less worried about the second concern, but I take your concern. Yeah. I hope I've answered your questions. Yeah.
We have a question here in the room, but there's also one on Zoom that I'm going to read out. It's also up on our screen. Heather is asking, I am confused about how this system fits with our existing legal system of liability, such as the recent Tesla self-driving car lawsuits that have found Tesla liable, in part, and for the decisions of the self-driving system. I'm just also confused about how engineers are personally responsible for ethical decisions at all, given that they are employees of companies and it would be the company that is responsible.
Yeah, so I'm not suggesting that engineers are personally responsible for the decisions. I'm just, in the argument that I made there, it was mostly about that engineers not having the moral authority to make certain decisions, right? The question of responsibility is an important, but I think a separate question. I think you can start, you can do some ethics modeling. Here, I'll fall back on this. You can do some ethics modeling to start sorting out questions of responsibility and a more kind of ethical liability. In the legal sense, yeah, sure. The company's the company's going to take the brunt of the legal liability. But engineers do, it depends, I suppose, on who's doing the service, and that's a little more complicated in terms of who's the engineer, who are they working for? Are they doing the work themselves independently? But that's a separate issue. I take the issue, or I take the point about that. Now, does this help? Would this have? So would an ethics modeling, let's say Elon Musk was a different person and decided to play around with ethics modeling at Tesla, and hired me to do to make some decisions about the autonomous driving system. yeah, it would have helped because there are certain things that there's certain decisions that Tesla has made that I mean that I've written about publicly that are just, I think, unethical. Their particular use of like the sensor package, so they don't use LiDAR, they only use like camera and radar, which no other car company has done that is seriously trying to implement autonomous vehicles. It doesn't give you enough data to make good inferences about what's in the world around the car. So I think that would have helped, but they didn't need ethics modeling to know that. Other companies were already doing that. But for example, the testing strategy that they've had with Teslas in particular, where they push these beta mode software packages into vehicles and then test them on public roads, I think you can use, well, what I've written about with Kate Hepner, a student of mine, and we presented it at a conference a couple of years ago, or like drawing from, again, like pharmaceutical testing regimes. So like, again, bioethics, to try to understand like what types of testing in public should be permissible and impermissible, and what limits should be placed on testing technologies that have life and death implications on public roadways, where you're not only putting the drivers at risk, you may make an argument that they're like kind of consenting to being part of an experiment implicitly, but certainly the other drivers and pedestrians aren't. So why are you permitted to test those systems on the roadways? Like Tesla admits that they're not production-ready systems. They're always in beta mode, which if you're from the software world, like Elon Musk, beta mode means that it's buggy and it has problems and that you shouldn't use it in production. Yet here we have, thousands of vehicles on the road running these public experiments. So I would argue that a little more ethics modeling at Tesla would make them a better company and a more trustworthy vehicle. It's a great example. It's why I'll never own a Tesla.
There's a question at the back.
Yeah, thank you very much for this talk. I really learned a lot. I have essentially the same question as Dr. Alexander, namely, why would we be talking to engineers rather than to business people or to politicians? So if I understand correctly, the proposal is instead of speaking about textual analysis, for instance, or instead of speaking about giving arguments, we now put all of this in a lingo that apparently engineers are better able to understand. We talk about building models or so. I mean, I think as a philosopher, so I think any philosopher of science would probably already get a headache over this, since it seems to be that building a model is something quite different from any of the things listed there previously, but okay. Let's assume we need to do this in order to reach the people that actually take the decisions. It seems to be the case that it actually isn't the engineers that are taking the decisions here. So maybe we should put all of these ethical considerations into a language of sales and profits in order to address business people, or maybe we should put all of these problems into a language of, I don't know, swaying constituencies or winning elections or something in order to reach regulators. It seems that most of these ethical questions fundamentally have to do with either profits or with regulation, right? For instance, a lot of the problems that you mentioned around privacy and so forth, that's ultimately a question of political regulation of these technologies, data collection, all of these things. So I'm wondering why the engineer would be the correct point of address here.
No, it's a great question, and I guess I'll start by saying, just by restating that I certainly don't want to suggest that this is a cure-all for technology. That's not how this is meant to work. 100% we need regulation. Like if we want to talk about AI, we need regulation. We need all sorts of regulation. It needs to be strict and enforceable and reasonable. We need real toothy regulations to protect against those harms. And so that involves having conversations with regulators. Business leaders, yeah, absolutely. I guess if when it comes to business leaders, happy to talk to them. I'd rather talk to the regulators because they force business leaders to do things, right? But I think the other important thing that I would raise, or the other important aspect, is that when, like, assuming we had great regulations for everything, like, let's just imagine a world with like fantastic regulations. Good regulations are incomplete, like in terms of addressing all of the potential harms that technology can kind of like deliver to society. So you know, regulation is great at protecting us from the worst cases, right? Like the most egregious kind of examples of harms, if it's perfect regulation. But you have then all sorts of ways that you could like all sorts of latitude when you're designing technology to design it this way or that way. And then sometimes you're just going to be designing a technology that introduces whole new categories of harms into the world that no regulation will ever, or that no regulation would currently protect against. So we have to have another backstop. Like there has to be something else, I think, operating out there as a part of the full set of like tools that we're using to make technology better, regulation, you know, like changes to the criminal code, like liability, all that stuff, and good design practice. Because there's a role for good design when you're making decisions about technology that are not, where it's legally permissible, but ethically problematic. And most design choices are like that, where the law, privacy is a great example. The law won't stop you from, you know, doing things that the average person would consider problematic from a privacy perspective, because the law protects against the worst cases. And so we need we need something else functioning in the world of tech design that helps identify and consider those cases where it's legally permissible but ethically questionable. That's that's the take I have on that. And engineers have all sorts of well, like their latitude in their daily work to make these decisions. They make thousands of decisions all the time that impact those zones of permissibility that doesn't make its way up to the business leader. It's part of the engineering team. Maybe they have a conversation about it, and if they don't have the expertise in the room, then it just happens. If there's somebody in that mix that's kind of their ability to check on some of these situations, like identify the situations that are like legally permissible but morally questionable, then the hope is that you would have a different kind of conversation in that moment. Because engineering teams have a lot of power to make those decisions. Business leaders can't, like they're not checking the work in all cases.
Do we have another question? Oh.
Hi, thank you. Thank you for the presentation. My questions, I have two. So the first has to do with why the answer to having the ethical problems is imposing a regulation rather than changing how we do things. I want to give you an example, just ChatGPT in this classroom, right? Why is the immediate default, let's find a way to restrict how ChatGPT can be used in the classroom so that we find ways to deal with the problematic issues, rather than perhaps maybe the way we evaluate competency being outdated now? So example, ChatGPT lets you write the essays. Maybe the issue is not find ways to prevent it from helping the students cheat, but instead finding ways to evaluate them that isn't based on essay. So I know for interviews, for example, with long distance, like you're doing a Zoom interview for a job or something, right? And one way to avoid the interviewee cheating with ChatGPT to answer some of your technical questions. They've been doing things like this, answer the next question with your eyes closed, please, or something like that. Just silly things like that that say, we can try to find ways to dodge this issue by evaluating your competency in ways that are independent of the risks that ChatGPT has. Right. So that's one question, is why is the first default to we need to regulate how they create these things versus we can adapt our processes to just better do it, and then it becomes a university issue, not an issue where we have to go to the companies. It's just we can change the university. And then the second is when it comes to an international issue, like because you had the weapons issues, right? You had listed it at the beginning that like auto weapon. I think about the war in Ukraine, right, with the automated drone fighting that they're doing and the technological advancements that have been made there. That seems like a very hard thing to regulate because it's an international issue. And when it comes to an issue internationally, we could say, okay, Canada is going to have rules on what things are acceptable and which things aren't. But then it means on an international scale, it doesn't really matter what rules we've implemented because unless everybody follows them, nobody's going to. We're just going to put ourselves at a disadvantage there. So those are the two questions.
So address those 2 points, yeah. Yeah, I'll take this, I guess I'll take the second first, and I hope I remember the first by the time I get there. Maybe you'll have to remind me, but I'll do my best. Yeah, on the, so on the international like coordination problem, like if there's one bad actor doing it, then it kind of upsets the whole balance. Like, yeah, so the folks that I work with who are, and I work closely with Minds Action Canada, who, and I guess this is the story. So I work closely with Minds Action Canada. Now, Minds Action Canada shared in the Nobel Peace Prize for the work that they did on the Ottawa Treaty, the treaty to ban the use of landmines, which was not signed by everybody, right? So the US never signed it. I don't know that Russia ever signed it. Like the superpowers, I don't think they signed the ban on landmines. But so putting in place, but the Ottawa Treaty happened, and countries like Canada ratified it, and so countries like Canada don't use anti-personnel landmines as part of their strategic defense, plan. What the folks at Minds Action Canada will say, and I'm 99% sure I'm getting this right, is that there's value in setting norms, like even if they're imperfect, right? Again, this is like a kind of a common. It's like it's that, what's the saying? Don't let the perfect be the enemy of the good, right? Like the shift towards, like when you've got 100 and some odd countries signing the treaties, it signals to the other few that they're that they're not in the majority, right? That they're being watched, that people are unhappy, like displeased with their particular choices on an issue. Now, it doesn't prevent the harms of putting more landmines in the world necessarily, but it reduces the overall number of landmines that are getting put in the ground, and it serves that purpose. That's what Minds Action Canada would say. It was like it serves a purpose in terms of signaling like where we should be going as a society, right? Like a global society. So, I guess that's the response that I would have with the second question, like the idea that if you don't have everybody, then it's kind of a waste of time. Or I don't think you said it that way. I don't want to characterize it, but like that it's imperfect and it hasn't really solved the problem, right? On the first point, why jump to regulations? I wouldn't suggest that like regulating ChatGPT in the classroom at a national level is an imperative that we should be jumping to. I don't think that's the right, we need regulations. I don't think that's one of them necessarily, right? But policies at the university can help pause the use of something until you study its effects, right? So what we have right now is like technology's out, boom, everybody can use it. It's accessible to everybody. Like, oh, we've democratized AI. And like what that means is like we've scaled it up and now it can impact like everybody on the planet in some way. And there, in many cases, we just need to do research and like figure out what the harms are that that we should be regulating against, I suppose, or have, policies at the university. I take your point. It's in many ways, I was in engineering, I went through an engineering education program at a time when people were still having conversations about the use of calculators in classrooms, right? Like, I had to have stickers on, like, different colored stickers on the backs of my calculators that they forced us to buy to learn the stuff, but didn't allow us to take into the exams, right? So they were worried that we weren't gonna be able to recognize an error, like on a factor of, 1,000, like on orders of magnitude errors, because we just weren't gonna be training our minds properly to, and was I a better engineer for being able to recognize those things and do stuff by hand? Maybe, I don't know. ChatGPT may be different, right? I think it's fundamentally different, the kinds of things it does. It's not just answering objective questions, like objective questions. It's kind of automating what 10 years ago maybe we still call it the knowledge economy, like trying to decide, on questions of politics and policy and persuasive argumentation, like things that calculators just don't do. So yeah, that's my kind of like longish rambling answer to the first part. That I don't think regulations in all cases are the solution, but in certain cases they can at least pump the brakes. Like not regulations necessarily, but policies, like at a university level. And that sometimes we're just going to have to change the way we do evaluations in order to compensate for the effects of some of these technologies. And I think you raised a couple of good examples in that regard, yeah, of ways that we can be creative in responding to technology. Responding to technology requires a number of different approaches, right? Yeah, including, I think, ethics modeling. Thank you.
Question right here.
Yeah, I thought your talk was really good, and you're doing some great work. This isn't really a technical question, just from my perspective, a lot of like ethical policies or thoughts are adopted usually after we see a catastrophe, like take the eugenics in Nazi Germany, or even lobotomies in the Anglosphere in the 50s, which kind of failed. Then they start, taking these concerns when people see that, or Chernobyl. People need to see the radiation and the disaster for I guess around the world to put in new protections or for air. So like, just like, how would you respond to people saying there would have to be an AI catastrophe to push like more ethical concerns from being adopted? Like,
Yeah.
Compared to like prevention beforehand, usually people have to see a major catastrophe and then it wakes them up to like take this more seriously,
Yeah, I mean, I'd respond with despair, but then I would be lifted by my optimism, because that seems to be the way that we do things, right? It's hard. These are big questions. It's hard to be optimistic, but I decided like years ago that this is kind of one of those things where you just like, you're trying to run a marathon, not a sprint, and nothing's going to change quickly. And so what I would say is that you chip away by finding this type of intervention, this being ethics modeling, that helps to contribute positively to the overall state of affairs, so that, without expecting to change the way that humanity responds to devastating technologies or to, existential threats. Yeah, it's hard to be optimistic sometimes, but I think there's so much, I mean, you don't want to live in despair, so So I choose the other thing. And
Again, I think you're doing like great work. I think this is important work. I'm just trying to.
yeah, no,
Yeah.
I mean, but I take your point. I mean, every once in a while, I'll read a news headline and just like have a bad day, because I feel like we're in that state where yeah, you're just waiting for the catastrophe before anything will get better, and you just hope the catastrophe is like contained somehow. But then again, optimism in other ways. I mean, I don't know, is this the human condition? I don't know. I mean, is there a branch in philosophy? Is there somebody here that's studying the human condition with regards to catastrophic? Maybe some, but yeah, I don't know. I take your point, yeah.
Hi, so I agree with what a lot of other people have said. This is a really fascinating talk. I think it's an interesting perspective, and I think I can see how it could be applicable, but that's where my question is. And this draws on something that you said earlier in your talk, that you said you talk to first-year engineering students and they're open-minded, and then you talk to third-year graduating engineering students or people who have been in their jobs for a while and that they've been socialized differently. And so it goes to that, and I don't know if this is something that you've thought about and where this idea of ethics modeling seems to be an approach, but I'm curious if you have thought about the implementation of it. Like, where do you introduce this? How do you introduce this? Does this become, like, what is your ideal optimistic view of it? Is this part of engineering curriculum? Is this part of how firms should be organized? Like, where does this belong? Where does it live, this ethics modeling? Like, where does it go once it leaves academia?
Right. So certainly in curriculum, this or something like it, right? Like, I'm not claiming that ethics modeling is going to solve the world's problems. If it does, great. I'm not anticipating this, but it's. I think it has promise. And so where do you introduce it? Yes, as early on as possible, I think, in engineering curriculum, first year. But it needs to be, but then, engineering curricula, they're funny things, right? Like, they're accredited and they're hard to change, but we can find places to put it in there. I currently teach some of these techniques at the grad level. It's too late by then, right? Honestly, I'll be teaching an undergraduate course in the winter term for the first time, bringing this type of thing into that curriculum. We'll see how it goes. I'm optimistic. In companies, I mean, when you walk into an engineering group at a company, like, there are all sorts of kinds of engineers in there, right? Like, depending on what type of work they're doing, mechanical engineers, electrical engineers, systems engineers, like, there are all these like subfields, right? And why? Well, safety engineers, like environmental engineers. So yeah, let's have an ethical and like an ethical design subfield that is like focused on doing this type of work. But really, the core knowledge contribution comes from ethics. It comes from philosophy, right? That's what we're trained to do, and we're good at it, right? So I do want to see a course like this cross-listed with philosophy, right? And get those students in a world together, like the engineers and the philosophers working on these problems, so that they can start to it's kind of how you do interdisciplinary education, right? You have to put those groups of students together. And so how does that translate into practice in industry? That's another type of challenge, right? So there are ways that you can work these types of things into standards, or I mean, there are many ways that I could imagine it happening. But we'll get there, yeah, I guess one step at a time. This is the first time I've talked about this in public, so so we'll see. Yeah, I mean, it's based on, like, you can tell it's based on a bunch of other work that I've done. I'm kind of like reframing it to make its applicability clearer and sharper. Like, here's where it fits, here's how it fits, here's the interface. Like, yeah, but great questions. Yeah, I think about all these things. Yeah.
Jason, we have a question also coming in through Zoom. I can read this one out as well. You may have touched on it a little bit. It's from Ramiza, who's asking, They're curious if engineers do cultivate a strong ethical lens. In what ways can this influence and ultimately improve the ethical implications of the technologies they design?
Do they? Was the question, do they cultivate? If engineers, in what ways can this? Yeah, so I can read that two ways. It's, again, my philosophy kicking in. So I can read this as, if engineers do cultivate a strong ethical lens, then in what ways can this stuff that you're talking about influence and ultimately improve? Well, I talked about that. I think that's the thrust of the argument, right? So it will provide a layer of analysis in the design of technology that is specifically focused on norms and ethical issues that translates pretty smoothly into design requirements and other things that engineers need in order to get to shape the technology while it's being designed. If engineers cultivate a strong ethical lens, in what ways? Yeah, there was another way that I was reading that at first. So maybe this is how I'm going to read it. My first reaction was like, do engineers cultivate a strong ethical lens? So I'll focus on that because I want to, and this point I want to make because I certainly do not want to suggest that engineers don't talk about ethics, especially in Canada. We've got the rings and all that kind of stuff for those of you who know about it. Engineering ethics is a topic that every engineering student learns about. It's taught in a very particular way. It's responsive to the accreditation and the legal obligations of the engineer as a professional practicing in a regulated profession in Canada. So engineers will be very quick, and engineering departments will be very quick to point out that they've been teaching engineering ethics for years, but they're not teaching any of the stuff that I talked about today. What they're teaching is a little bit of stuff about liability, like that you as a professional engineer will be or could be liable if you have a license and are working in a certain industry and signing drawings and stuff like that. I took a course called Disasters. It was a great course, but this is very typical of engineering ethics. The course was all about how technology, if it breaks, can kill people. And like we learned about Chernobyl and stuff like that, right? It was like Chernobyl, the Challenger. I can remember all these cases because they're like textbook cases of engineering gone wrong, right? Like the DC-10 crash. If you've never heard about that, you can look it up. Yeah, so I certainly don't want to give the impression that engineers are not concerned about ethics. We take when the Iron Ring ceremony, flawed as it is, focuses our attention on ethics. And it's like our version of the Hippocratic Oath, right? Like try not to kill people, make good decisions when you're doing design. But it covers mostly legal liability. And it doesn't, this is, I guess, just reflecting on the answer that I gave a couple minutes ago, it doesn't address the gray zone, right? Where there's all sorts of stuff you could do with technology, like put apps out there that develop a kind of attention economy, right? Like and just like have this and like drive addiction to technology as a strategy for gaining users and like, all the things that we know. That's all perfectly fine according to the laws and regulations right now. So they don't learn about that kind of stuff. And so that's where we need to fill some of the gaps. Like our understanding of the ethics of technology has changed radically since we put in place the engineering ethics codes and the rules. And I guess part of my concern is that we have to develop a very particular kind of sensitivity to ethics, or we can do that in philosophy departments and then work alongside ethicists to help, or alongside engineers to, as part of the design teams, helping to make those decisions as technology designers doing ethics analysis and ethics modeling as part of the ethics work that we do. So it does, like, part of what I'm proposing here is an alternative to relying on engineers for everything, right?
We had a question here.
Thank you. Thank you for the talk. I had a question about this kind of notion of mixing expertise, which I take very seriously, but I also have a concern. This may be a little bit related to Dr. Lobel's concern earlier in the talk about what we kind of consider legitimate within the sphere of expertise, because I think an ethics education is obviously very important, and there are people that think about these things like more deeply and more often, and there's like this language that we use that we can learn, which is very important. But at the same time, it seems like the people that are being affected by these harms of technology are not necessarily like professional philosophers or professional ethicists, or for example, like in biomedical ethics, you know, while I think ethicists have a lot to say, it's not, there's like a significant lack of overlap between them and like the patient. So I guess I'm wondering if you also envision a way to kind of consider the lives of people that don't have expertise in these kind of evaluations.
Yeah, that's a great point. And so, you know, some of the tools that are proposed for use inside of ethics modeling have to do with things like, say, participatory design or something like that, like where you're considering a broad set of stakeholders. I know some people don't like that term. A broad set of like affected groups or individuals who you then have to bring a voice, like you have to figure out a way to understand what the impacts are or implications are for those groups, and then make decisions about like how to, figure out how to make decisions about how to import that information, like that knowledge into the design process. It's messy, like everything else in that kind of, like when you're doing that kind of work. Policymakers struggle with this, right? Like how do you have good public consultation on policy making? You know, engineering, I think companies have not, like companies struggle with it. I think the ones who are big and have a lot of money attempt it more often, obviously, than the small ones. But I guess all I have to say about that is that that it's certainly again, the vision is not like that you're creating an expertise that's then going to be making decisions on behalf of other people necessarily. That in, I guess, in a like if you imagine the perfect world, that you'd find ways of bringing those voices into that process, and that you know, it may not be, you may not rely on ethicists in that case. It could be like, you know, sociology or anthropology. Like there are fields who have methods for kind of understanding how to draw on those. So like, you know, you find the tools that you need, and then you develop ways of bringing those voices in. Yeah, I think that, yeah, I'm not an expert in that, but you've seen over the years like many different types of proposals around those types of participatory design processes that I think could work, yeah, but that are always challenging because of practicality, like reasons of practicality, right? But that, you know, you need to use them. I don't know if that answers your question. It's just to like highlight that that I recognize it's a challenge, and that there are people that you could bring into the conversation to help solve some of those problems, or at least chip away at them. The goal being to move in a direction that's better than where we are today, not to solve all the problems necessarily, but like, again, it's like steering a ship, like a large, large ship. You just do your best to nudge it a little bit.
I realize it's getting too close to 5 o'clock, Jason. I think we could take on one last question, however, though, if someone does have one. It's fine, pass.
Thank you again. So I was wondering, in the ethics model, you have this technology in context, and on the right side of the inner box, right?
Yeah, I can see if I can.
Yeah,
zoom that
but
up
it
again.
doesn't matter that much. It's just that you emphasized that we should think of technology in a certain very specific context. That's what the application is, what
Yeah.
it comes to, and that sounds plausible to me. But I was wondering how the social context is chosen, and here's why I'm worried about that. Or I'm not really worried. I'm just interested in what you have to say about how to choose the social context in an appropriate way. Thinking technology has a tendency to be usable in very many contexts,
Yeah.
especially if we think about digital technology. I mean, the whole point is that Turing told us that the damn thing is universally
Yeah, it's
computable.
exactly.
So,
It can do everything.
yeah, so in some sense, it's very wide open. But you said,
Yeah.
for example, ChatGPT in the classroom, which was more
Yeah.
specific. So you might think, is the right context chosen as it were by the technology, as it were the context in which the technology can be used, or is it where we as engineers or as ethicists who choose the context that we want to work on? And if so, how and why, and are there limits to that?
I would say it's the latter. First, there's like the short answer, it's the latter. We can choose what context we do the analysis on, right? Like we can model technology in different contexts, and we'll come up with different, like there are many different models that will result, right? With different norms that come out of it, or different normative considerations. You could do ethics modeling in a mode where you want to critique the use of technology for something. And so you could choose whatever context you want. But the context matters. So the main point, I'll say the main point of that is to get away from what I see happening a lot, which is how should we design AI? How should we design autonomous vehicles? And the question is so abstract that it's meaningless. How should we regulate AI? It's like saying, like, how should we regulate computers or something like that? It's too broad, right? You have to drill down and get into the get closer to the place where that technology is going to be deployed or used in order to understand and start grappling with the norms that should govern its use or deployment or design in that context. Of course, we can't anticipate everything. Going back to the partiality of it all, you're doing an analysis on one particular context in one particular place maybe, but not necessarily in all. But the hope being that you could build up over time, if you're like designing in a company or trying to understand, the use of a particular diagnostic tool in healthcare settings in Canada, you could model it enough to get a pretty good sense of how that technology is behaving from an ethics perspective and where it needs to be modified, if we need new policies to use it better or more responsibly. But certainly that wouldn't necessarily mean that you've covered all the cases or all the potential misuses of the technology or so on and so on. Yeah. So it's really to get away from the idea that what you plug in there is just some broad, general, vague concept of the technology. How should we or should we not permit robots? Well, what do you mean? Robots in what context? For who? Like why? What kind of problems do you have in mind that they're trying to solve? Are they actually going to solve those problems? Like you have to really drill down. I think one of the reasons that we came up, that we hit a roadblock with AI policy in 2018 or whenever it was, when they came out with all the principles, everybody was so excited that they'd come up with AI principles, right? Like broadly speaking. And then immediately the people who were designing AI for a piece of diagnostic equipment in this type of healthcare setting, we're like, well, how does that principle translate to what I'm doing? Or like the person who's embedding some AI model into a car to detect lanes while you're driving. Well, I don't understand what fairness has to do with lane detection. I don't understand how to do that because it's too broad and vague, right? So that's what this is trying to remedy, is to get us closer to the ground so that we can identify problems that have some detailed contours to them, right? Social contours, and then start addressing those. Great question, yeah.
There was one final question on Zoom. I can read it out. From a BATM student. So given that ethical norms and laws vary across countries and cultures, the many AI systems we use are developed elsewhere. How can we ensure that these technologies adhere to our own ethical standards? And do you believe it's possible that we will eventually reach some form of global consensus on AI ethics? You did just touch on this, but.
Yeah, so I mean, we need to be sensitive to regional differences and cultural differences because they matter. They're going to, like a technology, I have this paper called Social Failure Modes, and I examine this exact thing. If you don't take into account, I'm sorry, and it gets to that as well, that like why I draw that box around technology and social context. If you ignore the local specificities around ethics and culture, a technology can just break. And what I mean is like it breaks socially. And it can have the same effect of it melting or snapping. It's not used the way, I define all this in the paper, but it fails to be used the way that it was intended by the design. So, and that's a failure, whether it's not used by anybody. That's a failure. The goal is to have a technology that's doing something and being used by as many people as possible, or that is relevant. And so, yeah, I have this whole thing about like how it could break. So if we don't take into account differences, things will just break in that sense. They'll break socially. They'll fail socially, and that's as bad as any other kind of failure in engineering. Do I believe it's possible we'll eventually reach some form of global consensus on AI ethics? I don't know if that's desirable. I mean, because it would maybe erase like some of the stuff that you're concerned about in the first part of the question. So is it possible? Maybe. Is it desirable? Maybe not. But that doesn't mean we can't have regionally relevant and meaningful AI regulations that protect those people everywhere against the things they're most concerned with, right? We see that in the EU. They're concerned with certain things. They've put in place regulations. They're not perfect. They're better than nothing. We don't have that. So write your MP. Write to the Minister of AI and Industry and tell them we need, as a response to this AI sprint that they've done, the AI strategy sprint, just tell them we need regulations specific to AI. That's what I'll end on. I'm ending on that.
Thanks, Jason. Let's clap.
Thank you. Thank you.
Okay, we can wrap up our live stream and our Zoom now. Give some people here in the space a chance to talk with Jason one-on-one. Just want to thank you all for coming in, of course. Thank you for your questions and your comments. Also, those of you joining us on Zoom, we're going to close that up. This does remain available on our YouTube channel. You can revisit it. You can reshare it. And let's see you next year for the annual ethics lecture. All right. Okay, have a great weekend.